That's supposed to be silenced, remember? Come on in. There are notes in your paper. Go ahead and write your name on it. We're going to get started. I was just telling them, Javante, that for right now, we won't have any algebra in here. Something all new. We're starting the actual geometry curriculum. So this is the introduction to geometry that we're working on today. There won't be any, honestly, it won't look like math for today. A lot of variables, a lot of terminology, vocabulary. So the very first thing we're going to talk about is a definition. What is a postulate or an axiom? So in geometry, sometimes we just have to be, they're going to tell us something is true, and we're just going to take their word for that. And those things that they tell us are true, that we're going to take their word for, we say they're accepted statement of fact. So we're not going to argue with them. They say it's true, we don't have to prove that. Okay? You don't have to fill in any of that other stuff. That's what Miss Rayleigh uses for her notebook, so I don't keep mine that way. I did that by your back window too. I'll make attention to attendance here, but I don't want you to miss your notes. Okay. Alright, so if it's a postulate or an axiom, they say it's true. That's something that we're never really going to have to prove. Kind of like the commutative property, the associative property, those kind of things, those properties we talked about in algebra, this is very similar to that. There are three undefined terms in geometry that we need to know. When we say they're undefined, it's because there's really not a way that we can define them without giving examples and descriptions. It's kind of like trying to define the word purple. How do you define the word purple? The color purple, right? Or lavender, except by saying it's a light purple. Well, what's purple, right? We learned our colors by examples, right? And there's some of these things are going to be the same way. So a point. When you think of a point, what do you think of, Kieran? When you think of a point, what do you think of? A spot or a dot, right? So for our purposes, so this black dot here is a point. But really, that point is just, that dot is representing a point. It's a spot in space, but there's not actually a dot there, right, in space, right? That's like saying we're in Tallahassee. If you look at a map, you see lines that are drawn and we're in Tallahassee, but Tallahassee is not, there's not lines around on the land on the map, right? We have to define that as Tallahassee. So this point, this black dot here, is representing that spot in space. So it indicates a location, and it has no size, right? It's just a certain particular location right here. Where these two lines cross, we could say that's point P. You're supposed to be writing in the red stuff, guys. You should have a blank spot there writing the red stuff. If you ever miss any, you can go back to the video. I'm probably going to record in 3rd and 6th period, and whichever one I think was a better recording is going to be the one that's uploaded to the module. So if you miss something, if you're out sick, you are supposed to get the notes. You have to go back and watch that video to get them. All right, so a point has indicates just a location, it represents a location, but it has no size. There's no dimensions or anything to it. All right, so a line, I did not cover up that. So a line is kind of the same way. It's a straight path that extends in two opposite directions without end and has no thickness. It contains infinitely many points. So we work with lines in algebra, right? We know that we learned that you can draw a line through any 2 points, right? In geometry, we're going to talk more about that. We're going to talk about the fact that there's only one unique line through 2 points. A line has distance, but it really has no other dimensions. that example with the two dots, R and S on it, you notice the arrows going left, the arrows going right. Those indicate it goes on forever or infinitely. And we have different ways that we can name lines. There are two ways that we can name lines. Yeah, you guys, Siri, you caught up with that? You got all the red spots there covered written so far? If you did not date these notes, it wouldn't be a bad idea. Just go ahead and date every page. What can it hurt, right? Make it easier to find if they have, especially if you don't have them stapled or in a binder yet. Can't hurt to date them every page as you get to them. So we're going to name the line in a particular way. We're going to learn how. If you go back, if you're done writing, go back. The way we name a point is just by having a letter beside it, right? So that point P, that P was just a label for that point. So we have a couple ways that we can label lines. We can use any 2 points. So for example, this line, we could call it line RS. And we read that little notation there, RS with the line over top. That's line RS. So there are 2 points on it. So you can name a line by any 2 points on that line. You can name a line by any 2 points on that line. You can also label it by a single letter. So in this case, this could also be considered line L. For some reason, well, when they label things L in math, they usually use a lowercase cursive L. But it could be line K, line P, line V, right? You can have different letters to label that line or to name that line. Any questions so far? A bunch of vocabulary so far. Stuff that you've seen a little bit before already too, though, right? So points on the same line are said to be, so think of, we're looking for a word that has the same, that line is the root word for. So that word is collinear. If you see inside here, you see L-I-N-E, maybe that will help you remember, collinear. They're on the same line. So these points R and S, they're collinear. They're on the same line. There's not really a fancy name. If they're not on the same line, we say they're non-collinear. Remember that negative prefix, non-collinear. So we just talked about that this one. Through any 2 points, there's exactly how many lines? How many lines are there could you make from 2 points? Only one line, no matter how many times I tried to draw another line. So for instance, this RS. I can draw a line through them here. But if I draw another line through them, the only way I can draw a line that touches both of those points is just to keep writing it right on top of the other one, right? So a line, there can only be one line through a given set of 2 points. Now, how many lines can I draw through 1 point? So let's say this is point P. How many lines can I draw through this point? Okay, I can draw 1. Right? Can I draw any more? Alvin says I can draw a canard that means perpendicular line. Can I draw any more? How long do you think I could do this? Yeah, what do we call that? So there's how many number of lines can you draw through 1 point? An infinite number, right? So we're going to get to that in a second. So through any 2 points, there's exactly one line, and the intersection of 2 lines is at a point. This is stuff we have to know. Your homework today is a bunch of words. Hardly any number, if any, I'm remembering. So if you're looking at that, look at that bottom. There's line. Who can give me a name of one of the lines there? Name one of the lines for me there, Jay. How would you name one of those lines? Line AD, right? So we can name the line by any 2 points on the line. So on that line going from the top left to the bottom right, it's got a point A and a point D on it. We call that line AD. We could also call that line AE. We could also call that line ED, right? The line has an infinite number of points on it, so if we have them labeled, there could be an infinite number of names for that line as long as we've labeled the points on that line. All right, a flat surface that extends, a plane. A plane is a flat surface that extends without any end and has no thickness. And a plane contains infinitely many lines. Go ahead and write that down and we'll talk about what the heck that means. All right, so a plane. You guys have had a little bit of basic geometry in middle school, I know. One of the ways we kind of describe what a plane is kind of think of a tabletop or a piece of paper. A piece of paper for me makes more sense because a plane has no thickness either. Like a point has no thickness, a line has no thickness. They're more like showing the distance between something or the path that something takes. So a plane, kind of imagine in your head, so you've got this, let's imagine it's super thin. So normally if you think of a piece of paper, we think it has no thickness, but technically it's super, super thin, right? Imagine that it's technically no thickness and extends infinitely in every direction. So it'd be like a flat, one little flat, like a piece of cellophane almost, that covers the same height flat forever and ever and ever. Does that make sense? Can you visualize that? So if we have any lines in this plane, they're going to all be going any direction like this. It says it has an infinite number of lines in it. So you can have lines going through this way, this plane, an infinite number, like we have here. It's like this is the plane, and all those lines could go forever. Okay? Now, if we have a line, there also could be lines not in the plane. So there could be a line that comes through and intersects this plane. So it comes up from the bottom, right? Imagine that a plane is a flat area that goes on forever and ever. It's more like a divider even than a seam. It has no thickness. Is that thoroughly confusing? No? Okay. So we name planes by, that's a picture of how we represent a plane in geometry. So what do you think one way we can name a plane is by looking at that picture? What do you think the name of that plane is? That is not a trapezoid. That shape, the shape that we're using to represent that plane is a parallelogram. right? So I see, what are A, B, and C? What would we call those? What are those? Points. And M doesn't have a dot. M is the name of the plane, right? So we can name the plane in two ways, just like we can name a line in two ways. So we can name it by a capital letter. This is plane M. But we could also name it by three letters that are on the plane, 3 points rather, that are on the plane. So we could also label this as plane ABC. We wouldn't just write ABC, we'd write plane ABC there. All right, so through any three non-collinear points, there's exactly one plane. So A, B, and C, we could draw a line through them, but they're not on a line right now, right? There's not a line drawn through them. Those are three non-collinear points. There's exactly one plane that goes through there. Javante, you gotta sit up and keep up, buddy. Points, what do you think the points that are on the same plane are called? What are points on the same, so points that are on the same line are collinear. What do you think points that are on the same plane are called? Hint, prefix the same, something. What do you think, Jay? Alright. Points on the same plane. So points on the same line are collinear. So points on the same plane would be what? Coplanar. You should have said it. You'd have been right. Coplanar. So points not on the same plane are said to be what? What do you think, Alexis? Not on the same plane, what would we call them? Very good, non-coplanar. Just vocabulary that you have to know, nothing hard. That bottom left image there, that is a sketch or a drawing of two planes that are intersecting. That red line shows where they intersect. So imagine one plane like this, and then another plane cutting through that plane, right? They intersect, two lines intersect in one point, but two planes intersect in an infinite number of points on the same line. So the intersection of two planes is at a line. All right, any questions so far? All right, space. So remember at the beginning of class we said geometry is a study of how shapes relate to space, and not as in outer space, but as in their location. So space is a set of all points in all three dimensions. Something that you have to know for this class is when you see a three-dimensional picture drawn, the dashed lines are lines that you can't see of a solid figure. So for instance, this is similar. This is a rectangular prism. It's a little different shape than that one. This rectangular prism, I can see the front, if I turn it to a side like that, I can see this edge, this one, this one, this one, this one. I know that there's some back here, but I can't see them. Right? If it were, when they're drawn, they use dotted lines to represent the sides, the edges, the vertices that we can't see. Does that make sense, Christian? Make sense? Okay, buddy. I've asked you a couple of times to sit up. Are you filling in your stuff? Let me see. Wait, so you're behind. We're a whole page behind. You want to stand up at my standing desk? Stay awake? Well, you got to keep your head up off the desk. All right. How many planes are shown in this figure? How many planes? So when we talk about how many planes are shown in this figure, how many planes do we use? There's a part of a plane in each of these figures, right? So I'm going to give you one. A plane ABC. So the side of that rectangular prism that has points A, B, and C, that represents a plane. If this were our rectangular prism, that plane would be this top one that extends everywhere from out from here. So plane ABC is the top. So can someone else give me the name of another plane that you see it?
There are 6 of them. Right?
There are 6 of them. Mm-hmm. So plane ABC. Now we could also label this plane BCD, right? There's multiple ways to name the same plane if we have more than 3 points on that plane. So there's 4 coplanar points there, A, B, C, D, right? Now, how about the plane that makes one of the ends? How would we label that, Kirian? What'd you say?
EH.
EH, the end. Okay, but we have the 3 points, right? EH would name the line that's that edge. We have 1 more point. Yeah, so EHD or DEH, any of those, DAE, that's how you label the planes that would extend from the faces of this rectangular prism. Does that make sense? All right, so there are 6, just like Leticia said. Name 3 collinear points. So there's only one side that has 3 points on that. So you guys see G, J, and F. Those are collinear points where that GF is a section of a line that goes through that side. And so we'd say that G, J, and F are collinear. There's 3 there. So name 3 coplanar points. Well, I named a couple of those because that's how you name the planes. So ABC, those are coplanar points. That's how we label that plane. Kirian told us DEH, those are coplanar points because that's how we label that end plane that makes one of the ends. The bunch of answers there. But plane ABC, that's that top plane we talked about. The top of the prism is in plane ABC. All right, so a line segment. That's where we are now. Line segment. This is an example of a line segment. How is it different than a line? How does that look different from the line we saw earlier? How does that look different from the line? Charles? How does that look different from the line we saw at the beginning of our notes? Good. It's got the dots inside. Look at the line RF at the beginning of your notes. That's too late. Well, look at that one. That has 3 dots. But remember, there's an infinite number of points in a line, so we could label as many as we want. Cleo? What's the difference between this segment? Ah, very good. So a line doesn't have a beginning and an ending point, but it doesn't have endpoints. A segment has endpoints. It's finite. Now there's an infinite number of points in between there, but it has a distance, right? A line technically goes on forever, right? We can measure part of a line. In this case, there's a line that goes through PQ. We could draw a line through that segment, but these have endpoints. So line segments have two endpoints. It's a part of a line that consists of two endpoints and all the points in between. So we only have the two endpoints labeled, but we could put another point in the middle there. So the way we label this is we can just say PQ. That's not how you're usually going to see it. These notes say that, but you're usually going to see it. You're usually going to see it like this. PQ, but with a segment over it. So you're going to see it with a segment, but no arrows on the ends. So it could be labeled like that, or like that. It could have a symbol above it, or it could not. So this PQ means segment PQ. And that's how we read this. If I were referring to this, I would say segment PQ. Okay? Any questions so far? All right, array. This is an example of array. How is array different from a line? How is array different from a line? It only keeps going in one direction. Khalil, go ahead and turn the sound off, everybody, so that doesn't happen again. Silent. Put it on silent mode. All right. So Alvin's exactly right. In this case, it goes on infinitely, but only in one direction. It has one endpoint, not two like a segment. Part of a line that consists of one endpoint and all the points of the line on one side of the endpoint. This is array. And we're going to write this. We can use any 2 points on array. Well, we have to start with the endpoints, right? So ray PQ is the same as ray PR. This is ray PR. Now there is another ray inside here. There's also a ray QR. Ray PR and ray QR are not the same ray. They have different endpoints. So we distinguish rays by their endpoints. So PR, ray PR and ray QR, they have different endpoints. So we need to make a note of that. They do not represent the same ray. Ray QR is inside of ray PR. All the points of ray QR also fall on ray PR. And the order of the points indicate the ray's direction. So we name these, the endpoint always comes first. So here you'll see that this is ray VA, but the arrow on top, that ray on top, always points right. I don't know why, it makes sense to me that you could point it left, but these things are usually labeled in alphabetical order too. So if you see ray AB, typically that means it's pointing to the right, or ray VA would typically mean it's pointing to the left. They normally label the points on lines and line segments in alphabetical order. When you're ready, if you could keep your head down, the next time you come into class and do that, I'm going to have to ask you to go to another room. Okay, have our head down in here. You have all the tools you need right now for success. You need to use them. You cannot be successful if you're not paying attention.
No discussion.
I can't hear you.
No discussion.
You what?
No discussion.
Yep. You guys done here? Alright, any point of the line divides the line into two rays, and they're called a specific kind of rays. Can we get you a pass, Jonathan? Your pass is on my desk. You're right in front of the little sign. Alright, any point on the line divides the line into two rays, and we call these opposite rays. Opposite rays. They're pointing in opposite directions. So collinear rays with a common endpoint extending in opposite directions. So there's 3 points on this line. What we're talking about, so you'll see that ray DE, so that's from this point in the middle of the line here, this point through E, we could say that that is ray DE. This, using the same endpoint D, ray DC, pointing the different directions. Remember, alphabetical order, non-alphabetical order, that tells us they're going in different directions. Two opposite rays, collinear rays, are just divisions of a line. Does that make sense to everyone? Is that it? Is that the last of our notes? Alright, so we have some time. Go ahead and get your Chromebook out and pull up your homework. If you want to pull it up on your phone, you can. Just leave your phone flat on the desk with Canvas pulled up. If you want, we can do a few of these together. Let's talk about some of these and give you some pointers. So you can see, I'll make this a little bit bigger if you don't have it pulled up yet. Alright, so let's look and make sure we're... So it says use the figure below for exercises 1 through 8. Note that line RN pierces the plane at N. So I'm going to explain what that means. Pierces the plane. So all of these, this is the plane. Line RN is going through the plane. So it's going in through the plane. Okay? So you're supposed to name 2 segments. Tell what the intersection of line CM and the line RN is. Any questions about what they're asking you to do there? That those directions make sense? All right, well, let's look at some of their others. So for these, exercises 9 through 14. You're not looking at that diagram anymore. You're just looking at what they give you. So ray GH and ray HG. Are those the same ray? Are they always the same ray? Are they sometimes the same ray, or are they never the same ray? What do you guys think? Alvin? Never true. How do you know, Alvin? Because they don't have the same endpoint. So on a ray, that first letter, if the letters are backwards, on a line, the letters could be backwards, but on a ray, you have to have the endpoint first. All right, let's do the other directions. If you want to draw a figure of two planes, you know, write your 7 hints. You look on your notes. We have the intersection of two planes on our notes. You can just sketch that same thing. You do have to put a drawing in there. It says draw a figure. All right, I think everything else is explanatory. Just let me know if you have any questions. You can work. I think we get out of here at 19. Nope, 16. So we'll pack up at 11:14. So about 5 minutes to work. I should see pencil and paper on everyone's desk. You have 5 minutes to work. If I had to guess, I'd say this assignment's going to take about 15, 20 max. So if you do 5 minutes now, you're only going to have 10 or 15 minutes at home. You okay for Charles? Yep. Now we have some paper. Remember, you're supposed to have a notebook. Yakesia, let's go ahead and send you down to attendance, finish for Joseph. You can go ahead and pack up. That way maybe you won't miss your next class. There you go. I'll see you tomorrow. Do you have your telephone given? We're working right now. We want no one's telephone given, so she's up there, but we're supposed to be working. Harmony? You're working.